Question overview. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Let's analyze this Google Cloud networking question together. We have an application deployed on Google Compute Engine that serves users through a load balancer. Now, we need to add a new feature that requires accessing objects stored in third-party storage. The key challenge here is configuring the proper network services to enable this third-party storage access. We're asked which option is not part of the solution. This is a tricky negative question that requires us to understand what's actually needed versus what's not relevant. Let me read through each option carefully and explain why each one either is or isn't part of the solution. This question tests your understanding of GCP networking concepts, particularly around network endpoint groups, NEGs, and load balancing configurations. Understanding the scenario. Before we dive into the answers, let's break down what we're dealing with. We have a GCE application behind a load balancer. This is a typical setup. The new requirement is to access third-party storage, which means storage that's outside of Google Cloud. When we talk about third-party storage in this context, we're usually referring to services like AWS S3, Azure Blob Storage, or other cloud storage providers. To access these services from our GCE instances, we need proper network connectivity. The diagram on this slide shows our current architecture and what we need to add. Notice how the third-party storage sits outside our GCP environment. This is crucial for understanding which networking components we'll need. The key insight here is that we need to configure network paths that allow our GCE instances to reach external storage endpoints while maintaining security and performance. Analyzing option 1. Let's examine the first option. Ensure the third-party storage is available and reachable to serve content. This is absolutely fundamental. If our instances can't reach the storage, nothing else matters. This involves several considerations. First, the third-party storage must have public endpoints or VPN connectivity. Second, we need to ensure our GCE instances have proper egress routes to reach these endpoints. In practice, this means checking firewall rules, ensuring our instances have external IPs or Cloud NAT configured, and verifying that the third-party storage provider hasn't blocked GCP IP ranges. The commands shown demonstrate how to verify connectivity and configure the necessary firewall rules. This is definitely part of the solution. We can't access storage that isn't reachable. Analyzing option 2. Option 2 suggests configure the external HTTPS with cloud storage as a backend. This is where things get interesting, and this is actually our incorrect answer. The key misunderstanding here is that cloud storage refers to Google Cloud Storage, not the third-party storage mentioned in the question. We're trying to access external third-party storage, not GCS. While you can configure an HTTPS load balancer with cloud storage as a backend for serving static content from GCS, this doesn't help us access third-party storage services like AWS S3 or Azure Blob. This option represents a common confusion between Google's own storage service and external storage providers. It's a classic misdirection in the question. Analyzing option 3. Option 3. Configure the external HTTPS with the Internet NEG as a backend. Now this is exactly what we need. Internet NEGs are designed specifically for this use case. An Internet NEG, Network Endpoint Group, allows you to define endpoints that exist outside of Google Cloud. This is perfect for integrating third-party services into your GCP load balancing infrastructure. With an Internet NEG, you can add the third-party storage endpoints as backends to your load balancer. This enables sophisticated routing, health checking, and traffic management for external services. The configuration shown demonstrates how to create an Internet NEG pointing to external storage endpoints. This is definitely part of our solution. Analyzing option 4. Option 4 mentions create an Internet NEG that uses the storage's FQDN. This is closely related to option 3 and is also correct. When creating an Internet NEG, you specify endpoints using FQDNs, fully qualified domain names. For example, if your third-party storage is a WSS3, you might use an FQDN like my-bucket.s3.amazonos.com. The Internet NEG resolves these domain names and manages the connections. This option emphasizes the practical aspect of how you configure the Internet NEG by providing the actual domain names of your storage endpoints. This allows for DNS-based endpoint discovery and failover. The ability to use FQDNs is crucial because third-party services often use DNS for load balancing and regional routing. This option is definitely part of the solution. Analyzing option 5. The final option. Configure the external network load balancer with the Internet NEG as a backend. This sounds plausible but contains a subtle error that makes it incorrect. The issue here is that network load balancers, Layer 4, don't support Internet NEGs as backends. Internet NEGs are only supported by HTTP/S load balancers, Layer 7. This is a common misconception. While network load balancers are great for many use cases, they're designed for load balancing to instances within GCP, not to external Internet endpoints. If you need to access external HTTP/S endpoints like third-party storage APIs, you must use an HTTP/S load balancer with Internet NEG, not a network load balancer. Complete solution architecture. Now let's look at the complete, correct architecture for accessing third-party storage from our GCE application. This diagram shows all the components working together. Notice how the HTTP/S load balancer can route traffic both to our GCE instances, for the main application, and to the Internet NEG, for third-party storage access. This gives us a unified entry point for all traffic. The Internet NEG contains the FQDNs of our third-party storage endpoints. When a request comes in for storage content, the load balancer routes it through the Internet NEG to the external storage. This architecture provides several benefits: centralized traffic management, consistent security policies, integrated monitoring, and the ability to cache responses at the load balancer level. Implementation commands. Let's walk through the actual G-Cloud commands to implement this solution. These commands show the complete setup process from start to finish. First, we create the Internet NEG, specifying the network endpoint type as Internet FQDN port. This tells GCP that we're pointing to external endpoints. Next, we add our third-party storage endpoints to the NEG. Notice how we specify both the FQDN and the port, usually 443 for HTTPS. Then we create a backend service that uses this Internet NEG, configure health checks appropriate for our storage service, and finally add everything to our HTTP/S load balancer configuration. Each command includes comments showing what it does and what you should expect to see. This gives you a complete implementation guide. Summary and key takeaways. Let's wrap up with the key points from our analysis. The question asked which option is not part of the solution, and we identified 2 incorrect answers. Option 2, cloud storage as backend, is incorrect because it refers to Google Cloud Storage, not the third-party storage we need to access. Option 5, network load balancer, is incorrect because network load balancers don't support Internet NEGs. The correct components of the solution include ensuring network reachability, using HTTP/S load balancer with Internet NEG, and configuring the NEG with the storage's FQDN. Remember, when integrating external services with GCP, Internet NEGs with HTTP/S load balancers are your go-to solution. They provide the flexibility and features needed for reliable external service integration.